Hello, community. So great that you are back. Why do our AI agents still fail? Now, I can tell you because we do have a massive AI reasoning disaster at our hands. Let me explain. There's a beautiful study about the danger of overthinking, especially for agentic tasks, and they examine here the reasoning action dilemma. And you might say, yeah, of course, in your last video, we were talking about overthinking, yeah? And there was an easy solution, especially for the distilled R1 models. Yeah? And I got some response back from my viewers, hey, YouTube is full of now MCP server. Does an MCP server help us? Okay, so for those of you who missed my video here 3 months ago, I was talking here about secure MCP protocol bidirectional. You understand this is just the standardized way for our models to interface with external data sources and tools. So, although there is a strange thought I will come back at the end of this video, that we are now looking here at the models, and you know in my last video we looked at the R1 distilled model. And this is the video for it. And I asked now myself, okay, what we found, especially the easy solution to our overthinking problem, is it also valid here for non-reasoning models? For a GPT-4 Omni, Omni Mini, for Claude 3.5, for a Sonnet model, for an O1 model, an O1 Mini. What about those models? Is our simple solution working? So, this danger of overthinking, as we will find out, is a real big problem for the complete reasoning LLM sector. Our AI agents, they fail in their reasoning. And you might say, but we built now these new reasoning models, no? We built this test time, compute, scaling, and everything. And yes, some of them are working in a very narrow domain, but in general, they fail in their reasoning. And here we have a team from UC Berkeley, from the ETH Zurich in the Schweiz, Department of Urbana-Champaign, Department of Computer Science, Carnegie Mellon University, and they examine exactly this. No? Look at this. They had a detailed look and they said, we now define what is overthinking in general for all the models. No? And they say it's a behavior tendency where our LRM, this is a new abbreviation, large reasoning models. In my last video, I showed you another author group used here the reasoning LLM notation. Now we have the LRM notation. It's all the same. Where our large reasoning models favor here extended internal reasoning over some effective environmental interaction. So doing something, an action and a feedback. So writing a piece of code, generating an answer. This is overthinking here. And we have a non-equilibrium between the thinking, the internal reasoning, and actually doing something as an LLM. The key problem is if you want here this reasoning action dilemma. And the agent faces here a trade-off between thinking more internally, just making sure it makes no mistake, versus simply act as an agent in the environment to get a feedback or generate some code or write some answer. So here we have the dilemma. They analyzed here UC Berkeley 3 symptoms of overthinking. We have an analysis paralysis. So we have some extensive planning in the inside of our AI agent, in the internal thinking, generating long reasoning chains, known as chain of thoughts, with minimal concrete actions. Then we have the rouge actions. No? So we have actions in a single turn without waiting for a feedback, assuming success based on the internal evaluation. So we don't wait for a real-world feedback. The model just assumes, it's going to be okay, I can continue, and this is going to be okay, I can continue. And yeah, we run into some major problems with the reasoning. And then, especially with O1, we will see we have premature disengagement. And this means the system simply says, hey, terminating a task based on the internal assessment perceived here, or a task perceived as this task is not solvable. I don't want to try to solve this. I just say, this is the end. Ciao. Or you have overconfidence. We give a complex problem to an AI and the AI says, hey, I think about step 1, step 2. Yeah, this should be it, no? I'm confident that this will be the solution. And it just stops thinking. This is not what we are looking for. If you want to have it a little bit more flashy, so analysis paralysis is like getting stuck here in the thinking phase. and never getting to the doing phase. These rules actions are just ignoring the fact that the first step failed and that the later steps are now also impossible or invalid. The system just ignores this. Or, with a premature disengagement, the AI decides a task is impossible without really trying to solve it, or the AI just thinks it's finished successfully without actually checking if the result makes sense. Yeah, this is what we encounter in today's system. So let's look here for a spark of genius to find here a solution. Let's have a look at the results that the authors had. And as you can see, we have a higher overthinking scores, strongly correlates here with a lower task success rates. So the more internal thinking is happening, we have less actually doing of the system. Then we have explicitly optimized for the reasoning, so our O1 or R1 and QWQs show significant higher tendencies to overthink compared here to general purpose model like the Sonnet or GPT-4 Omni model in the non-thinking mode. And while older models suffer, especially the non-reasoning models, the older models show here a steeper performance decline when they do overthinking. This is not a good result. Plus, lower reasoning effort here, especially they found in O1, so fewer reasoning token, led to a higher behavioral overthinking score, suggesting that insufficient reasoning can also cause poor interaction patterns, not just excessive reasoning. So if we have not enough reasoning, and then the system should do something, and the reasoning is not preparing his strategy, or at least a plan, step 1, 2, 3, the interaction that should happen is just pure chaos. So we run into problems on all corners of the system. Let's have a look here. Yeah, higher overthinking scores. So the more you are here to the right, this is not what you want. You don't want that the system is just playing here with itself internal reasoning without doing anything. Let's have a look at this. What you notice immediately, we have here DeepSeek R1 and DeepSeek version 3. They are real beautifully positioned here. No? The resolved issue, yeah, it's here in the upper half, and here in the overthinking score, it's real close to 1. So yeah, this is here from DeepSeek R1 beautifully. This is where you want it to be. No? But then look at this. DeepSeek R1 32B. Now, if you have seen my video, you understand that this is not R1. This is a QN model that has been supervised, fine-tuned on the R1, if you want, thinking traces. But look where this model is. We are at 5.7, 5.8 in the overthinking score. This is not where we want to be. But you know what? This is what you are working with if you have it locally at home. Because when you work here with an R1 model, you don't work here on the, 1 terabyte of VRAM, but you work with a quantized, maybe you have a 4-bit, or you work also with a distilled R1 model. And you see, this is now that a lot of people I talk when they say, yeah, I have this at home. No, I can run this. And even if you have a 5090 with 32 gigabyte of VRAM, yeah, but this is where the model really shines. This is the performance of the model. The model that you download in a quantized version and in a distilled version. And here in the notation, you don't even see, if you go with Olama or anything else, you don't see that it's a distilled version. Because the official name is DSR132B. But we know as experts that, of course, it is not a R1 version. It's just here a distilled version. And the base version for this is Q1 2.532B. So we do have identically sized models, but something in the distillation process for the complex reasoning path is not optimal, as you can see here in the overthinking score. So therefore, if you use this at home and you write here in the comments to my video, I used R1 at home and it's a complete different result. Now in this study, I can show you yes, but it is for a simple reason. Of course, you as, I don't know, a student or whatever you are in a university, if you don't go here in the cloud, that you really have terabytes of VRAM, but you work here locally, you don't have the computer infrastructure for this model. You have to go with the distilled model. And maybe you even have to go with a quantized distilled model. And then you're in deep trouble because for no way you get the performance of a real R1 system. So careful. But from a theoretical point of view, we do encounter now the question, hey, how is this possible? The R1 is here. Version 3, the base model for the R1 is here. And the Q1 2.532b is here, not as good, but still here around 2. Why suddenly we have this bad performance if we go here for a quantized distilled version? Well, if you have an idea, please in the comments. However, how do we measure that? Because maybe this is just the wrong measurement, no? So always check it. So this is based here on some ideas that were published here on SWE Bench. Then we have here this idea, if you want, the code act, this executable code actions for the better LLM agents, and then the implementation was with open hands. So these 3 papers give you here, explain to you in detail how the experiment was built up, and this was the experimental setup, and you have seen the results of this. If you want to know more about the open hands execution pipeline, I have here some additional information for you. Now, of course, as I told you, the main question now for us, if you look at this for AI research, we have to think, why doesn't DeepSeek R1, the full version, overthink? Why doesn't DeepSeek R1 or the version 3, the base model for the R1 version, overthink? Why is this not happening in the huge models? Now let's come here to the core idea of all of this. And here we have now a brand new study published yesterday for me here, March 27, 2025. And here we have, people ask me to read all the institutions. Shanghai AI Laboratory, University, Westlake University, Peking University, Tongji University, Hong Kong University of Science and Technology, Tsinghua University, and the Chinese University of Hong Kong, and others. And they have now a beautiful survey. And this, I really recommend. This is a beautiful overview, brand new, really including the latest technologies and the latest insight in the reasoning method. And they give us here a simple thing. No? What is the square of 3? And if you use a Q1 2.532b instruct model, you see it takes 30 tokens. If you use a QWQ32b, so the same model size, it takes in total, if you sum this up, 1,248 tokens. So this means the difference between these 2 models is 41 times the number of tokens. How is this possible? What is happening here? Let's look at something else. Let's look here at, this is now a combined mathematical problem from 3 different mathematical benchmarks, never mind, but it's just the distribution of the generation length here. And in blue, we have again our Q132b instruct model. Look, the generation length or the number of tokens is here rather limited. It really finds the solution fast. But if we go again with a QWQ32b, non-instruct but general model, you see we have much more tokens that we need here for the reasoning process to find possible solutions. So there's something happening. Look at this example. We have a simple query, translate here a single Chinese sentence, how to think efficiently. I hope this is really what's standing here. Into English. What do you think? How many tokens do we need? More than 2,000 tokens by reasoning model. And you might say, why? And you know what? This is already what I love. This is really brand new data. Look, there's already Gemini 2.5 Pro experimental 0325. Just 2 days before this was published, they still used it, the really latest one. So beautiful. Thank you to the authors. I appreciate if you really have up-to-date models and benchmark of up-to-date models. But how is it possible to translate one sentence that you need more than 2,000 tokens? What's going on here? Now, it turns out we have, in our set of different AI modules, we have 2 extremes. On the one extreme side, we have this kind of agent. And if you ask this agent, hey, 2 plus 2 equals, this agent will tell me 360.2711 degrees Celsius. And I might say, but this is complete nonsense. Yeah? And the agents will say, this is it. Absolutely. I insist that this is the solution. And then on the other end of the spectrum of agents, we have this little agent. Now, this agent has been trained in a different way for the complex of reasoning. This agent might say, okay, so wait, so let's break your exercise down. Wait for the number, but wait, would this mean, so let me check, hey, let's verify this, and then, okay, therefore, but in early equation, wait, let's compute that, wait, let me double check, but wait, let me think again, but wait, so let me check once more, so going round and round and round and generating tokens ad infinitum. Now the question is, which agent are you working with? Do you know exactly what is your agent, the behavior of your agent? And yeah, this is this is not just an idea. This was a real screenshot here from this video that I showed you. Now, in their survey, which I highly recommend, that they encounter here again redundant content in the thinking of our agents. Repetitive phrasing, I just showed you. Unnecessary verification steps. You don't need to verify it 8 times in the identical methodology, or focus on textual coherence over the reasoning process. Then we have overthinking simple question, excessively long reasoning chain. I saw a question with 15,000 tokens for a simple equation. So, long reasoning chain for straightforward problems. And we have an incoherent and suboptimal reasoning. We have an underthinking in the complexity. So some model prematurely just switch reasoning paths, You decide you go for a particular mathematical methodology, and then the model halfway says, no, today is Tuesday, let's do something else. This is what we encountered today. Please read the study to find more information about this. Countermeasures. So what we do against this. The complete AI community in AI research is currently working on this. This is a hot topic if you want. And here from the survey, you see some of them. So efficient reasoning during inference. What can we do? Length budgeting, system switching, model switching, parallel search. Efficient reasoning with supervised fine-tuning. What can we do? Compress the reasoning chain. Efficient reasoning with reinforcement learning. Length reward without length reward. During the pre-training, subquadratic attention, linearization, and. And you know what? This is so beautiful because those are the topics of the videos of the last 2-3 weeks that I showed you. Look, Stanford 1 here, length budgeting, the perfect example. Or look at this, new abstract reason here, sketch of thought, just I think a week ago, or less than a week ago here. In the end, Cosmos Reason 1. I showed you here the physical AI system that also trying to fight here the reasoning complexity with a subquadratic attention and Mamba mechanism. Or if we go for further future directions here, overthinking an agent. This is here the first study I showed you here at the beginning of this video. So you see, everybody's trying to crack open and find a solution to this overthinking, to this problem we encounter currently in AI. And here, very nice here also for the reinforcement learning methods with a length reward here, they show you here the different reward functions. So if you are interested to work in this topic, have a look at this. They really list here what they are trying, and you see none is really the perfect solution. So there is something to be done. There's research waiting for you because this is an unsolved problem we have currently with our AI models. So if you want here, this survey here discusses here the reasoning efficiency and the problems in general and possible solution that we already found, where this, the first one that I showed you today in this video, this danger of overthinking, shows you why it's critical for our agent that we use and why our agents fail. And you might think building your agent network or your agentic structure or whatever you have, that it is the interconnect, that it is the communication protocol, that is MCP or whatever. It is your LLM. It is your main pure reasoning core. that has a problem because we do have a reasoning action dilemma. Overthinking that simply leads to task failure. So let's talk about this reasoning token versus overthinking. Now, finding that fewer reasoning tokens here, for example, with the O1 model from OpenAI, here can lead to a higher behavioral overthinking score. Of course, because your system should do something. Your AI should generate code, should generate an answer, should generate, I don't know, an image. No? And if it's not doing this and does not provide a strategy how to proceed with the action, you have a higher behavioral overthinking score now. So this is not what you want. But you can have both ways. No, this is funny. You can have too fewer reasoning token. So this leads to bad decisions, like high overthinking score or low quality in your answer. But you can have too many reasoning tokens. This leads to inaction. This is our analysis paralysis example. You have high cost, potentially low quality if the environment changes or the interaction was needed. So therefore, it is again about this equilibrium, the true efficiency that we are looking for. Just the right amount of reasoning token for the given complexity that we have to find, and we have not found a solution yet. So this overthinking is a really costly symptom. And I mean, you pay for tokens if you have a commercial model for the reasoning inefficiently we encounter today, especially damaging if you use agent in your AI structure. And improving here the large reasoning model, reasoning capability requires not just making here the thinking process faster or shorter, but ensuring that the reason efficiently informs here the action and adapts to the environment feedback. And we are also failing on this particular topic. So this effective reasoning, this balancing here, the internal computation complexity with the feedback of the environmental interaction manifold, this should be, what we're looking for if you say about a true intelligence in artificial systems, but we have not achieved this yet. I would like to draw your attention to this very interesting paper. This is here from Tencent AI Laboratory in Shanghai Jiaotong University. Overthinking of O1-like LLMs. And they focus here really on this O1. Really nice. They claim the paper here presents the first comprehensive study on the issue of overthinking in these OpenAI O1 models, where excessive computational resources lead to minimum benefits. And you remember, OpenAI O1, you pay for the thinking tokens. So let's come here to the next sector here. MCP, yeah, this was a question. I received quite a lot of questions. Why not MCP? Is this not a solution to everything? Everybody's talking about it. You understand that MCP doesn't directly cause or cure the behavioral pattern of overthinking. Neither analysis paralysis, nor the root action, nor the premature disengagement here. This is here the model's internal decision-making process. However, there are ways MCP here could really exacerbate here the overthinking, because it could theoretically enabling longer chain. So by making it feasible to run much larger model or chains together, more complex computational path during the inference, this MCP might generate now even longer and even more elaborated internal reasoning sequence. If you do not control your MCP with a specific guidance, or you constrain here the complexity of MCP. So theoretically, you could get even more problems with MCP if you do not really understand what's happening. So an infrastructure removes some computational limits, but the behavioral tendency might remain. But I'm not only looking at the negative case of MCP, because only theoretically, speculative, I think it could theoretically help us, but not the current MCP. We have to go further in the development of MCP. Let me explain why. Why MCP facilitates the dynamic scaling compute based on the perceived task complexity, it could theoretically, in my idea, maybe I'm completely wrong, help us. Because allocating fewer compute resources, so simpler path, less reasoning for straightforward parts, reduce here our overthinking on the simpler steps. So this would be something that we are looking forward to. No? And then for more complicated tasks, we just allocate more compute resources here within our MCP. But this means that we do have to have specialized model components for MCP, in my idea. No? Because if MCP connects different specialized submodules, you have a fast action proposer or a detailed planner or a feedback interpreter, this sophisticated agent architecture must be built now on top of the MCP protocol. No? And the idea is to potentially route requests much more intelligently than the current MCP protocol does it, because we are already working in a multi-agent complexity. So if we have now this idea, this environmental feedback arrives, the request might go now not to the deep planner in just one agent, but to a feedback interpreter. So we have here an architecture, an agent architecture built on top of the MCP protocol with the interpreter. And therefore, we could break here this problem here where we ever encountered the problem of the analysis paralysis cycle. But careful, no, this depends entirely how the models are designed to use now MCP and not just the MCP protocol itself, because we have to build on this model multi-agent architectures in the future. This is just my idea. But if you want to do some PhDs or whatever you're interested, hey, why not play around with this one? So therefore, we could say MCP primarily is an enabling infrastructure protocol, not a reasoning strategy. And in this view, you could say MCP is just a tool for us. Yeah? But without careful control, it could also enable here models to engage in even more extensive and potentially real unproductive internal reasoning. So MCP is not at all done. MCP is just entering here the arena, and we have to have a lot of optimization on different levels, however you want to see MCP, just as a tool, as a protocol, or even a little bit more as an intelligent protocol with some modules in the models itself compatible. My goodness, AI research. We have tons of research to do. Yeah, let's come to the next one. You remember in this video I was talking here about NVIDIA, the developed world AI, the Reason 1 model the latest model by NVIDIA. And yeah, I was asked if I show this, where is the video? Now, here is the title of the video. I mean, this is why I do a screenshot. You know, I go there and I make a screenshot, and here you see the title. Forget LLM, NVIDIA, Reason 1 explained. And then I got a question here in the comments, and yeah, but where is the title? And I said, it's really there. It's a screenshot. No? And then I got back an answer that was really amazing. I said, yeah, but I don't want to read your title. I just want to see here the thumbnail I can click on. Okay, so if you learn better, I do everything if you can accelerate your learning. So this is the video, and this is the video thumbnail if you don't want to read the title. If you would read the title, you would find that this title here is identical to this title. Hello. Yeah. But you also remember here in this video with this title, we were talking here about we want to understand why certain decisions were made. We want to go deeper, no? We want to have here a modeling of our basic ideas, no? Of the latent sorts. So this could be also another path forward. Or if you remember in this video with this video thumbnail, we were talking about if you have a QNQWQ, and we looked in particular at the argumentation structure, or the all-one argumentation structure. We found the line structure, tree structure, network structure, graph structures. And then we were looking here to deconstruct those long chain of thought reasoning argumentation to a simpler one, to get loose of all what we do not need, come to the minimal set of reasoning arguments. And then at the end of this video here, I showed you how to go from deconstruct the long chain of thought to a distilled long chain of thought. But now this was just the side problems. Now to the main problems we will encounter in AI research in the next weeks and months. And this is simply, just think about Google DeepMind, just published here, Gemini Robotics, bringing AI into the physical world. You remember this? Yeah, this was the thumbnail to my video. And we were talking here about the development of Google DeepMind, how they see AI in the future, no? The Gemini Robotics family. And they have more or less a similar idea to NVIDIA. And I showed you the videos from NVIDIA N1 and NVIDIA Reason 1. And now here we have more or less a very similar idea by Google DeepMind. So we have two ideas, so two models here. We have Gemini Robotics and Gemini Robotics here, ER. So here we have, if you want here, vision language action model. So you immediately understand if I tell you this is an action model. This is here to control here the robots actuators here in detail. So this is here really, if you want, how you control the robot for particular actions. And therefore you have to understand here the vision and the language command, but you have to transfer this to actuator command. So the robot is really doing exactly what you want. Move forward, hold on to something or whatever. While the real, if you want, intellectual path is done here in the Gemini Robotics ER, this embodied reasoning. And yes, we have again here reasoning, but now we are in multi-modal reasoning. So we increase here the complexity of our reasoning structure from a pure linguistic reasoning level to a multimodal linguistic level. And you might say, yippee, this is exactly what we needed because we fail already on the linguistic reasoning complexity. And you know what? Now, the real funny thing is that the Gemini Robotics builds on top of the Gemini Robotics ER model, which makes sense, of course, because this model is, if you want here, integrates the sensor stream, looks around, says, oh, I'm in a kitchen, I see a fridge, I see a table, I see some chairs, I see, I don't know, something to eat on the table. And then if the robot has now the task to go to the fridge and get the milk out of the fridge, then it has to transfer this knowledge here for some specific movements by the robotics actuators. And now the way they build it, it is a distilled version. If you see distilled version, you remember my last video where I showed you that especially in the distilled version of R1, we have a reasoning overthinking that breaks our model. And I showed you an easy solution. But this was for R1. Now we are talking about Gemini, no? Well, in this video, and this is the thumbnail of my video, if you don't want to read my title, they already found, Google found, hey, we have a problem because look, we have a thought collapse. So they come from a complete different perspective on argumentation and reasoning, and they thought it's a thought collapse. Now, in reality, it is not a thought collapse, it is a reasoning collapse that they encountered here with their model. And they said, we find that when the rewards are based on the action outcomes, our reinforcement learning fails here completely here for the chain of thought reasoning in our vision language model. Instead of having as what we want, we have a collapse of our thoughts, we have incomplete reasoning, and we have invalid action, resulting in negative rewards, and the system fails completely. So you see, this is about, I don't know, a video more about 2 weeks old. For 2 weeks, they published this because they found out there is this problem. So you see, wherever you come from whatever direction, from whatever polarization you come, we encounter the same problem. We have a problem with reasoning. Robotic reasoning, agent reasoning, vision language reasoning, pure linguistic reasoning. We have to solve this problem. And 2 weeks ago, they published this to counteract here the thought collapse, as I've shown you in this video. They establish a process guidance. So they establish here a corrector AI that refines the single AI agent reasoning at each reinforcement learning step. So you have your big brother AI watching here the reasoning, the small brother AI reasoning here. But imagine if you don't have always a big brother correcting you. Sometimes you have to be on your own feet and you have to make your own decisions. And what if the big brother too makes an error? You have a corrector for the corrector? This is not a solution going forward. So we are encountered now with some massive problems, with some massive reasoning failure in all of our agents. And it is not the fault of the training methodology of a particular company, of a global corporation. It is happening in all of our models. So this is, for me, a clear indication we are not just talking about an effect, but we are talking here about something that is happening to the core of our AI. But of course, to make it a little bit more complex, because we want to have fun, we are now adding here the complexity of the complete visual reasoning methodologies, no? Because we are not happy that we are just dealing here with a linguistic reasoning. now at the same time we push forward our robotic systems. So this means we have not at all solved the reasoning problem in linguistic, and now we put on top of this here our problems with visual reasoning, and I think it's just funny. It's just amazing. It's just absurd, you know? But AI is pushing ahead. Every global corporation is pushing ahead, and you see exactly where they are working on. Day on, every day. And you know, the beauty is I can explain the videos of my last 2 weeks because, as I've shown you here, they all come together. They all converge on one problem point. We have not solved AI reasoning. Outlook? Yeah, Outlook is of course my next video. It's raining outside. I have to go outside a little bit, walk in the rain, get the rain on my face, and yeah. Isn't it beautiful? Isn't it gorgeous to be in AI research? And you thought AI is already solved and we already have achieved AGI, or whatever you call it, super hyperintelligence. We don't have even solved the basic problems of AI reasoning. Hey, why not subscribe and be surprised by my next video?